Hi class, it's Bill Berry here, and we are introducing design patterns in week 5 of our Java 2 class. We're going to talk about what they are, what they're good for, and then we're going to look at one sample one just to kind of get us started, and we'll use some other ones in our work later in the quarter, so this will be a good start for understanding this. And by the way, design patterns also a great place to work in the future, great place to study in the future if you want to get in a little deeper while you are preparing for other academic programming courses in the future. So let's jump in and get to design patterns. So one of the taglines that I like in one of the books that I'm going to show you starts out with, "Someone has already solved your problems." So what are design patterns? Well, design patterns are conceptual. They are not an API, they are not a library, a framework, they are none of those things. They're a higher level of thinking. You can think of them as being more in an architectural level. You can use various things to implement them, sure, but they are not themselves. You don't import them or you don't copy them literally from somewhere. They're going to be frameworks, right? They're concepts. They are going to help us, though, make our stuff easier. So you're going to see that very often somebody in the industry has done many, many times what you're trying to do in a general way. So by implementing it that way, by following their ideas, you can make your work easier to understand, easier to maintain, more flexible, and also can help us avoid common pitfalls, right? So the reason that they publish these things is because there are well-known solutions. So rather than reinventing the wheel, so to speak, you might as well use the thing that was already created, right? What somebody else has already been smart enough to figure out, not only that, but adapt and used and honed over time. So you'll find, of course, many places to learn about these things, and we're going to talk about a couple of books, and they're definitely going to be in a couple of the projects that we're going to use this quarter. I'm introducing the Singleton because I think it's an easy way to get started. It's an easy, simple pattern to get us started, and then we're going to use some that are a little more complex, and then we're going to look back and realize that we already have implemented a couple of design patterns too once we get a little farther back. So let us now look at a couple of the texts. If you really want to look into these more deeply, of course, websites are a great place, but if you really wanted a classic old book to page turn and read, what could you find? Well, the definitive text on this is called Design Patterns, and it's written by the group known as the Gang of Four. It's these four folks that listed here. The ISBN is here, and that is the scholarly text. So if you want to have the classic one sitting on your shelf, and I'll find professors that have this book sitting there, right? So you might be able to take a peek at it if you happen to be on campus and you can ask. So you want the scholarly book, academic book, get that one. If you want something that is a little more fun, a little more interesting, a little quirky, then think about this book, Head First Design Patterns. All of the books that they create, it's from O'Reilly, and all of the Head First books are a little bit quirky, right? They're going to be funner. They are going to have examples that are going to be non-academic and more interesting. Sometimes not even computer science related, but sometimes just strange. Making pizzas, having ducks that, making toy ducks that quack, period, right? There's going to be all sorts of funny, interesting little ideas that are used in here as examples. So don't expect this to be necessarily very academic, but it is fun, right? There's fun, interesting little drawings. And if you want something that's a little off the beaten path, then maybe consider this book. They also have an object-oriented programming book, but so these are two books that you may want to look at if you are trying to get started with design patterns. One of the other things that I like about design patterns, maybe going back to this idea of this particular slide, you are going to hear about these in computer science life. So they are part of the vernacular that you are going to hear about when you work in the industry and are looking into the industry. So one of the cool things that I like here is that when you hear a certain word, a whole architecture comes to mind. That's the cool thing about a design pattern, right? It talks about a whole architecture and is encapsulated in a word. So when somebody says the word factory, they're talking about something very specific in terms of design pattern, and so with a single word you can communicate a big idea. When you talk about Singleton, you are communicating a big idea. So that's the other nice thing about design patterns, is that you'll be able to communicate and think about things or have a starting point for things based on a popular and well-tested idea. So design patterns, cool stuff. There's the books. So we're going to look at one simple one just to give us the flavor, give us the idea of what a design pattern can do, and give us a very simple one to start with, and that's called the singleton. And the tagline that I've assigned it here is once is enough. Not once is never enough, but once is enough. So what does the singleton do? Well, the name kind of gives you a hint. The singleton design pattern's purpose is to limit the number of instances. It's to limit the number of objects that get created from a specific class, and you're limiting it to one. Notice that you're not limiting it to none, right? You are limiting it to one instance. So by creating that, by limiting it to one instance, it starts to feel like instance data is almost a little more like static data in that it's going to only be used one time, right? It's one per class. Notice though that we are not eliminating instance data. We are still using instance data. In fact, we're using it throughout our code just like we would have used instance data before. The only thing is we know now that there's only going to be one instance in existence at a time. So don't think that we are eliminating instances and only using statics here. It's a typical error in code. You still write instance data because later you may change your mind, right? Later you may decide that the singleton of I only want one of this thing ever during the run of this particular code, you might change your mind and you might want to switch it out, and you don't want to have to go redesign all your code and go fix everything. So it's still pretty flexible. So what are some of the places in which you might see that used? Well, you might only want one printer spool, for instance. You really don't want to instantiate multiple printer spools trying to talk to one printer. Logging services, drivers, right? Often one is exactly what you want, and it should never be more than that. So sometimes a shared resource is a good place to use a singleton. You also could think of it in doing a front end, where you don't want some code in your project to accidentally create more than one graphical user interface, for instance, right? One, during the run of this particular app, maybe you don't want to have multiple of these graphical user interfaces popping up because they might conflict with each other. Plus, what does the user mean, right? By having multiple of these things up, what would that even mean? So these are just some ideas. They don't have to be used in any particular circumstance, but sometimes it's just very convenient. There's a reference here. Tutorials Point is a site that I like. They have very simple, straightforward information, and so when they offer something about a particular topic, that's not a bad place to go. All right, so let us also be aware that singletons are not a single solution that are going to solve everybody's problems. They have some downsides, and you'll find plenty of anti-singleton talks on the web, and people say they hate them for various reasons. Okay, so just for full disclosure, I'm just telling you, yes, there's going to be detractors, and you don't want to use them willy-nilly, so here's some things. Right? One of the things that we're going to see is they make unit testing difficult. Right? We're going to see some information about that in a while. We'll have a special slide talking about that, but they are going to make unit testing a little bit more interesting, and we'll talk about why. Also, if you use the classic code that's given, it may not be thread safe. So if you have multiple threads trying to work through some of these on these problems, it may be that you'll want to use some workarounds. You'll want to use some additional code to make sure that with multiple threads that your singleton is still going to do what you want it to do, not going to create bugs. The other thing is the state of this is going to be the lifetime of the session, right? So it's not that when a particular instance goes away, or even when the last instance goes away of a particular class, you're still going to have that thing running, right? You're still going to have this variable because it's going to stick around as long as the class sticks around, because you're gonna have, as you'll see, you're going to have this static that's going to hold on to something. So The other thing is it's not necessarily a great solution if you're going to do subclassing. So you may want to remove it if you decide later that you're going to want subclasses. It may not be your best friend. And again, it may sound great today. Tomorrow you might want more instances, but it's not prohibiting you from doing that. The architecture is not so ingrained in what you do that it's going to make you have to throw away your code or start from scratch, etc. So it's still going to work okay. Just wanted to make sure you know there are some downsides to it, and sure, you're going to see some haters. Doesn't mean it's not useful when it's useful. All right, so how do you do it? Let's look at it. It's a very simple concept, right? I only want to make one of a thing. So how do I do that? So let's look at some code that would create it and how the concept is implemented. First is, your step number one is you're going to define a private static variable, and it's going to hold a reference to the single instance that you're going to allow. So think about this for a second. You're going to define a static variable that is going to point to the instance, the one instance that you're going to allow, right? So this static, again, that's going to say that's going to stick around. That's going to be one per class, but it's actually pointing to an instance, right? So again, we're not giving up all instance data. So what does that look like when you do it? Well, you create private static. This is a private variable, and you name it, right? If the name of the class, this can be anything, right? This is any class that you want to use it on. In this case, I just called it Classic Singleton because it's borrowed from that sort of classic code. And you create a reference to one of these, and you set it to null, and you don't have to call it instance. That's not a particularly magical name. In this case, we just have chosen the word instance. But this thing is going to be a reference to the single instance of that class that you're going to have, right? So step number one, make your private static. It must be private. You don't want to give access to this through any other mechanism, and you're going to see why. So it needs to be private, needs to be static, needs to be of the same data type, reference as the class that you're creating it for, right? All right. Note down here at the bottom, pay attention to what's static and what's instance. That's important here. If you get that wrong, then you can make some mistakes in the singleton. So that's step number one. Step number two says you make a private constructor. Now that is a strange concept that we might not have thought of before. Because maybe you think, well, if I don't want somebody to construct the thing, why don't I just make it abstract? Well, no, we need to construct the thing, but we want to control that ourselves, and we want to make only one of the things, right? So it's not that you don't want it constructed, you do want it instantiated, so it's not an abstract. But if you have no constructor, remember Java will substitute an empty constructor, and that's not what we want here either. So this is a cool trick which says if you make a constructor but it's private, then nobody from outside can instantiate it because they can't get to the constructor. Clever idea, right? Private constructor. So what does that look like? Looks like this. You make a constructor just like before, but instead of public in front of it, you say private. So interesting. Now nobody from outside can get to it, or another way that you think of it is this defeats instantiation, right? Nobody can instantiate an object of this class. So that's a key here, right, in making sure that the singleton is managed the way you want. But that's not enough, because if that were the case, then how do you make this single instance, right? How do you do that? Well, that comes in step number three. You provide a public static. Notice now public, right? So client facing or client available static method that returns the instance that is in the variable declared in number one. And the other key is creating it if it doesn't exist. So what does that look like? You create a public static method. Now, because it's a static method, what can it access? It can only access static data, right? But this reference is, in fact, static data, so it certainly has access to it. And the magic here, brilliant, is, and notice this is a common name. Again, it's not magical, just like instance is not magical, get instance is not magical, but it's a very typical thing to do. And in fact, if you poke around in Java some, if you're looking around at some of the classes that are provided, some of the date calendar kinds of things, you're going to have seen get instance before. And get instance, again, public static, has to do a couple things. The first thing says, if the one instance variable, right, or the static variable that points to the instance, if that is still pointing to null, that means no object has yet been created. So if that's the case, make a new one of these things. Well, wait, isn't this private? Well, yeah, it's private, but that means we can still get to it from in this class. It's just you can't use it from outside. So we can still instantiate, and we do, and we assign it to this variable, which is the static variable which holds the single instance. So now we have created the one thing if we needed it to, and then regardless of whether we created it or whether it was already created before, we return it. So when outside folks, outside coders need access to us, the way that they get it is not by instantiating, but by asking for get instance. If we need to, we create it. If we don't need to, we don't create it, right? So that is how we limit this to one instance of the class. Now, like many of the design patterns, when you look at this thing, afterwards you go, wow, that was awfully simple. Like, that seems like a very straightforward kind of thing. But the question is, would you have thought of it, right? Would you have thought of implementing this? And the answer is, well, maybe not right at first. It might have taken you some time, and I don't know whether we would have come to this. But once you see it, you go, yeah, that's kind of the way that you should do it. So it seems very, very straightforward and very intuitive in retrospect, right? So now again, when you're talking and say singleton, like all of this comes to mind, the single instance, how you might implement it, all of that stuff is conjured by that single term, the name of the design pattern, which is a singleton. So super cool, super easy. Now, if we go and look at a sample of code, right, just to make sure that you've seen one other thing, it's not that exciting, all right, I'll show you. It's going to be implemented just like we were talking about here, right? Whatever the class name is here, I have a private static variable that is referring to an object of that type, and I'm setting it to null. This is where some of the thread safe stuff is going to happen, but that's another topic that you can look up if you care. The point here is you can have whatever other instance stuff you need, right? You don't have to make everything static here. So other instance data, you just treat it as instance data, right? Then you make a private constructor, right, which defeats instantiation. It can still have parameters, right? It can still do whatever it needs to do. Then you make a method like getInstance, and it's going to be static. Again, because it's accessing the static, then this can be static. This could not it could not access anything that is instance specific, right? But it can certainly access the static, which is all it needs to do. And it says, hey, if I've not created one yet, then create it. One way or another, return that. So subsequent callers will still get a reference to the same object in memory that was created here. Right? Everybody gets the same one. And then you just go on with whatever else you need to do, right? You still can have get and set methods. Again, they don't have to be static. You don't want to make them all static here, because later you might want to remove this architecture, and it's really not that hard, right? You can take out what makes it singleton without any particular amount of effort. So cool stuff, right? A very interesting little design pattern to get us started, easy to understand. And so over here in main, what do you do, right? If I tried to instantiate it, obviously that's not even going to compile, right? Because it says, hey, the constructor is private, can't do that. So instead, I have to say, get the instance. And down here, if I wanted to make another one of those, if I wanted to create another reference, I could say only 1, 2 equals, and then I could once again say only 1 get instance, right? But these two variables are going to point to the same thing. So if I look to see whether 1 was equal to 2, the answer would be it sure is, right? It's the same thing in memory. So if I did a little if statement and printed it, we would always find, no matter how many of these things you create, they are going to point to exactly the same thing in memory, because that's the whole point of the singleton, right? That's how singletons work. Okay, so a couple of quick wrap-up things, some challenges that go along with singletons. So remember I said testing is going to be a little bit more interesting, a little bit more difficult. Why? Well, in the past, when we were testing objects, writing JUnit tests, we were just creating objects all the time, right? Potentially in every single test method, we create an object and do some stuff with it and test it, and then we discard it, right? We just let it go out of scope and poof, there it goes. But remember now, there's no poof out of scope, away it goes. There's no garbage collection done here. So what you have to realize is you're not starting in a clean state. You're not starting necessarily every test at a point where you know what's in it. So we're always in the same, getting the same reference to the same one that was used after some other test ran. So you don't necessarily know what's in your object at the moment your test begins. So this is where you got to be really thoughtful about using something like the at before and at after tags to make sure that you reset everything to a state that you know it, and then you can move forward. So in our project where we're working with documents and document workspaces, right, we have a project in which we're doing sort of a word processor back end. You have to think about when you start the test, you want to make sure that your before or after step has always put it back to a known state. Maybe you clear things out, zero things out, empty things out, put in the sample data again, but you're responsible for doing that. Think about before and after in a more important way here. The other thing is we have this variable that we called here instance. One important thing to know about is do not mess with that variable. I should put this in red letters. Do not mess with this. In your code, you might think that you can just set it to null in your class somewhere because you think that will help it get reinstantiated, right, recreated and start fresh. No, 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 that is not good. Because remember, if somebody else already has a reference to that, then your old thing is not getting garbage collected and replaced the same way that you think. So somebody in client area could have a reference to the old one. So never mess with this variable. Only change the contents of this variable in the prescribed ways that we have talked about, never any other way. All right, so don't use it. There's several points here that if you're in my class and you're actually writing a project with me, then read over these things really carefully as reminders of ways that students will often do bad things here by messing with the instance variable, thinking that they're solving problems. So if you're trying to go down that road, don't go down that road. You're creating a problem for yourself. So hopefully you see some of the interesting stuff that we can do with design patterns. You see the allure of them and the fact that they can be super useful and they can communicate a lot. And hopefully the Singleton gives you some ideas, gives you a starting point, and you say, wow, that's kind of a cool little idea. Sure, I could remember that and potentially use it in the future. So there's so many more interesting things about design patterns, and we'll certainly come back to a couple of key ones. One of our main ones that we'll talk about later is the observer model. Again, super simple and elegant and beautiful, and it solves the task in a very, very nice way. So appreciate you watching these videos. I hope that you're learning a lot, and I look forward to seeing you, as it were, in another video. So come on back and continue the series. Thanks.